Hello everyone, it is Campbell. Today we're going to be discussing molecular forces. Molecular forces are an important and fundamental concept in chemistry because molecular forces determine the shape of molecules, the structure of entire compounds, chemical properties such as boiling or melting point, and they determine how molecules interact with one another. There are two types of molecular forces, intramolecular and intermolecular. Intramolecular forces occur within molecules. They are what hold molecules together. This comes from the root word intra, meaning within. There are three types of intramolecular forces, including covalent bonds, ionic bonds, and metallic bonds. Covalent bonds are where two atoms in a molecule share valence electrons. This occurs in many different molecules, including water, carbon dioxide, sugar, and plastic. These bonds occur because atoms are the most stable when their valence shell is full, and some atoms can fill their valence shell by sharing electrons with other atoms. These types of bonds are very strong. Ionic bonds are bonds that form salts. They occur between a metal and a nonmetal when the metal donates an electron to the nonmetal. These bonds cause crystal lattices to form because of the highly similar dispersion of electronegativity. Ionic bonds are also very strong bonds because they happen between positively and negatively charged ions. When the metal donates an electron, it becomes a positively charged ion, which is very strongly attracted to the now negatively charged non-metal, since opposites attract. Remember that in ionic bonds, atoms do not share electrons, they donate electrons. Metallic bonds are bonds that occur in metal materials. These occur when valence electrons sort of become more of a cloud, and they move around on a sheet of positively charged metal ions. There's not really an organization to the electrons, so as you can see in this diagram down below, valence electrons simply move anywhere in the sheet of metal atoms. Next are intermolecular forces. Intermolecular forces occur between molecules. This, of course, coming from the root word inter, meaning between. They determine the chemical properties of substances, such as the melting or the freezing point, and there are three types of intermolecular forces. Dipole-dipole is the strongest type of intermolecular force. This type of attraction occurs between partially charged or polar molecules where the electrons are generally static. This doesn't mean they don't move, but when they do move, they maintain the electronegativity in one area of the molecule. A great example of dipole-dipole attraction is hydrogen chloride, as you can see in this diagram up here. This is a covalently bonded molecule where the hydrogen is partially charged to be less electronegative, since it is sharing its electron with chlorine. The chlorine is partially charged to be more electronegative. The dipole-dipole interactions in this molecule will, of course, occur between the electropositive hydrogen and the electronegative chlorine. Hydrogen bonds occur between hydrogen atoms that are covalently bonded to highly electronegative atoms and other highly electronegative atoms. These include oxygen, nitrogen, and fluorine. This is the interaction that water molecules, certain acids, and our very own DNA uses between base pairs. Hydrogen bonds are also very strong. You can see this diagram down here at the bottom. It is showing the boiling points of different substances. So we've got some of these substances over here, such as water, hydrofluoric acid, ammonia, and methane. As you can see, the ammonia, the hydrofluoric acid, and water all have relatively higher boiling points than some of these other things, such as methane, since methane cannot hydrogen bond. Finally, we have London dispersion forces. These occur when electron movement within a molecule causes an instantaneous dipole. This instantaneous dipole can affect the shape of other molecules around it due to repulsion between electrons and can cause very weak attraction between molecules. London dispersion forces can be a little more tricky to understand. It helps to remember that electrons are constantly moving around within an atom, like I mentioned before, and sometimes it also helps to imagine the electrons as a cloud. And if the electron cloud moves to become more dense on one side of the atom, it will repel other electron clouds away, and it will weakly attract the positive side. Unlike hydrogen bonding, which can only occur between hydrogen, nitrogen, oxygen, and fluorine, or dipole-dipole attraction, which can only occur between polar molecules, London dispersion forces affect all types of matter simply because electrons are always moving. So let's go ahead and review. I'm not sure why that was part of an animation, but remember there are two types of molecular forces, intramolecular and intermolecular forces. Intramolecular forces include covalent bonds, ionic bonds, and metallic bonds, and these occur within a molecule. They hold molecules together. Then there are intermolecular forces, which occur between molecules. They are what hold entire compounds together. Intermolecular forces include dipole-dipole attraction, hydrogen bonding, and London dispersion forces. Remember that dipole-dipole attraction is the strongest type of intermolecular force, and London dispersion forces are the weakest type of intermolecular forces. And that is just about it for molecular forces. This was just a very basic introduction. I wanted to let you guys know what the molecular forces are, what the two different types are, what they include, and how they differ. If there are other topics in chemistry you guys are interested in, please feel free to leave a comment. I would love to cover what you guys want to learn about. If you liked this video or if you found it useful and informational, please consider leaving a like and subscribing for more videos like this. And that is just about it. So I will see you guys next time. Bye.